be the moderator after this, and then maybe we can start, yeah. And while waiting, and we can shift the opening speech
Yeah,
from Pak
later.
Nugroho and
Yeah.
Professor Chu in the after your presentation, I think, because we are already our attendants already waiting. So let me introduce the first. Maybe Amala, you can introduce one by one our speaker.
Okay, good afternoon and welcome to today's webinar, Hestia Eco-Digital Platform, Sustainability Assessment of Farms, Food Manufacture and Product Supply Chain. We are so happy to have you, all of you join us for this insightful discussion on digital approach to sustainable assessment. And this event is proudly organized in collaboration with Hestia, the University of Oxford, and BRIN. And before that, we will have the opening speech from two of our honorable expert in this topic, but unfortunately they cannot meet the agreed time. So after this, we will continue to have the webinar starts with the speaker. So our first speaker is Juliet Effler. Hi, Juliet.
Hiya.
Hi. Correct me if I'm wrong, because Juliet is one of the data data modeler.
Yeah, data analysis probably a bit more generally, but yeah.
Oh yeah, the data analysis for the sustainable agriculture from University of Oxford, and she will be speaking about that topic. And also we have the second speaker, who is Joseph Ore. Hi, Joseph. Are you there? Okay.
Yeah. Hello.
Okay.
I think I'm actually the first speaker, and then Juliet's going second, right?
Yeah. Yeah. Okay, it's also okay. And also the third speaker is Patrick Henriksen. Hi, Patrick. Everything's good there?
Good morning, everyone.
Good morning there. Here in Indonesia, good afternoon. It's still cold right there. I wonder. It's still covered with snow. Beautiful.
No, so
white snow.
I'm actually I'm currently with Leiden University as an assistant professor, but also work one day a week for Stockholm University. So I'm between.
Oh, okay.
And I'm currently in Amsterdam.
Oh.
But it's also cold here.
Good so. Okay. Let's start with the webinar itself. So I will hand this webinar session to our moderator, Mr. Augusto.
Yes.
And yeah.
Thank you, everyone. So let's start with the first speaker, Dr. Joseph. So for attendance, so you can you can make a question in the chat box, or you can ask directly after the session. So for the first speaker, Dr. Joseph, time is yours.
Okay, thank you very much. I'm just going to share my slides. Let's see it. Oh, that's kind of cool. I'm not doing that. So is that, are my slides full screen?
Now
Yeah,
they're
they
full
are.
screen.
Yes.
They weren't full screen, no. Let's try a different one. How about now?
Yeah.
Presenter mode,
there's
not full screen.
now it's
Now
fine.
full screen.
Yeah.
Now it's full screen.
Yes.
Yes.
Now it's fine.
Okay.
Yeah.
Thank you.
Okay.
So I'm just sharing some results of some previous research. Basically, myself and a colleague brought together lots of life cycle assessments globally on the environmental impacts of different food products, covering multiple indicators in the full supply chain. And we're able to generate results like this. So these bars show the range of greenhouse gas emissions from the 10th percentile to the 90th percentile, which is the top of the bar. So bottom to the top is 10th to the 90th percentile emissions for like a beef producer per 100 grams of protein. So what you see is there's a lot of variability. The lowest impact beef farms compared to the highest impact, there's typically something like a 10 times difference. And if you look at beef from the dairy herd, there's like kind of a 20 times difference. So very big differences within the same product. There are also very big differences between products. So beef, for example, is causing on average something like 50 times more emissions than peas, for example, for the same amount of protein. And I was also able to generate results like this. So how much is the variability in land use within a product and between products? So this variability is across farms. So I had data from 40,000 farms. Maybe I had about 1,000 beef farms, 500 lamb farms, something like that. So you got this variability across farms and across products. And what this says is, I mean, obviously there's a clear pattern. It's better to eat plant-based food if you care about the environment. And it also says that we need to know what the environmental impacts of these farms are. Like, it's really important to both, try and get this information, make this information more available, so we can understand which farmers are the most sustainable, which are the least sustainable, which products are the most sustainable. You could also generate results like this. So for any specific farm, you could look at what are the drivers, what are the main sources of greenhouse gas emissions. So, for example, for this Australian wheat farm on the top graph on the left, you can see that the dominant source of emissions is direct N2O emissions from synthetic fertilizer. The next farm, their main source of emissions is residue burning. The next farm, the top one in the middle, the Cyprus irrigated wheat farm, their emissions are coming from diesel, using a diesel pump for irrigation. So that's the main source of their emission. The one at the end, the Nepal raised beds one, they're importing fertilizer from China, and that's China's got a very coal-heavy grid. So that's a big source of the emissions for Nepal. So you've got this ability to also look into what the environmental impacts are, understand your drivers, so hotspot analysis in LCA. And this also says that we need to both know what the environmental impacts of farms, of products are, but we also need to know what is causing those impacts to be able to tell them, okay, for this first farm, you should target your synthetic fertilizer use. For the next farm, you should target your residue burning, etc. So you can see the reference down in the bottom left if you want to read that article. And in 2018, Patrick and I were discussing like what it would take to do something a lot better. And since then, a lot more advanced, like really bringing together data from many more LCAs, really bring them into one place, harmonizing them, and pulling out all this information that is kind of, available. So we've been building Hestia for about 5 years. And the goal is effectively to reduce the environmental impacts of food by providing data and models that we need to quantify those emissions, reduce those emissions, and regulate improvements. Obviously, we publish as well. So Hestia provides 3 resources. A data format to harmonize and exchange data. Juliet's going to talk a bit more about this, but in brief, everyone represents data on agriculture and the environment in different ways. So one farm survey is not comparable to another farm survey in general. One LCA, the data, how they represent it, is not comparable to another LCA. Your activity data might be different. You might have different names, different units. You might have different kind of levels of completeness, different levels of metadata. So we've created a format to try and solve that problem, just to get data comparable. And that is if we can solve that problem, it's just a massive step forward in our ability to work with these data collectively. So we're effectively creating a kind of common language for agricultural sustainability data. We make available a data platform, which at the moment has data from 100,000 cycles, which is roughly the same as 100,000 farms. We've got that data from published peer-reviewed studies. Like published life cycle assessments, published industry reports. We've had data contributions from a range of organizations. And Juliet will demo this in a bit, but we're able to basically provide similar, we're getting able to provide similar data to what I was showing on the previous page, kind of average impacts of products, data at the specific farm level, and we make it all available on a free and open source basis, and it is really a community project contributed to by a lot of research organizations globally. So these are the organizations so far that we are working with to grow data on Hestia, and the map shows the distribution of data on the platform at the moment. And thirdly, as Juliet will show, we basically we've coded up about 500, maybe 600 models to take data and run, take activity data, so data on your inputs, products, practices, and effectively run a life cycle assessment analysis over that to calculate your emissions, your resource uses, and your characterized indicators. So effectively automating the LCA process right back to the kind of on-farm emissions modeling. And we enable compliance with the EU's EF and GHG protocol, for example. And the key point of this is our models will run automatically if you get data in our format. So once the data is in our format, you just upload it and the models run, and you get a kind of full LCA out with like some of the most, the most recent modeling. And the goal of that is to really scale up LCA to make it faster and easier for everyone. So I'm just going to quickly talk through some applications of Hestia. Our data format is forming the basis of policy in the UK and potentially in Europe. So you can screenshot this if you want. There's a link at the bottom right which has a policy briefing if you're interested in this. But in brief, our data format allows sharing of data in supply chain. So not just between researchers, not just for LCA, but it allows any sustainability, product level sustainability data to be shared in supply chains in a harmonized way. And that's really critical to unlock information exchange, sustainability data exchange. our data can be used, our data format and data platform can be used to share information describing entire research stations. So this is Rothamsted Research in Devon. We've basically structured up all of their data into our format and make it available on Hestia. So we're really unlocking these big data archives, and this is extremely complicated, detailed time series data, which we are able to represent and share. We also make available big farm surveys. So this is a farm survey from CIMIT on 30,000 farms, where we've automated the LCA process. So you upload it and we automatically do an LCA of all for each of those 30,000 farms. You can also on Hestia on the platform, which Juliet will show, you can go in and access really detailed data describing all the activity data underlying a kind of product or a farm. And you can also get data on the kind of average environmental impacts of products. So these are all of the kind of average impacts we've got for India on the platform at the moment. And what we've done is basically taken all of the farms, averaged them, and generated these kind of average impacts. You can see that sesame seed and sunflower seed have the of the crops have the highest impacts. Potatoes, onions have the lowest, and you've got a kind of range in between. We also make available kind of average data on fertilizer use for crops in countries. So if you're familiar with FAO stat, they give you total fertilizer use at the country level. We're giving fertilizer use at the crop level for each country where we have it available. So effectively a product version of FAO stat. You can also build new emissions models from the data on Hestia. So we don't just store model data, we also store measured data. So measured, let's say, soil carbon data, measured enteric fermentation data, and that you can use to train a new model. So we're working on a kind of new tier 3 soil carbon model at the moment. You can also take our models and effectively embed them in your own software. So all our models are free and open source, and you can basically download them and install, basically put them in your own software. So this is a company that's put our models in their software, and they're looking at all these fields on one farm. So this is one farm, all the different fields that are growing wheat. And you can see in this case, all of their farms have got greenhouse gas emissions below the global average, but they're doing that through very extensive practices, and their land use is almost always higher than the average, suggesting there might be indirect greenhouse gas emissions, and that actually, the land use is their big challenge. But those green dots on the right, the land use per kilogram dots, show that this farm does have some fields with pretty efficient land use and low greenhouse gas emissions. So therefore, our models have allowed them to identify which wheat growing fields they're farming in the most sustainable way. And hopefully they can then scale those farming practices to their other fields. We also, our models are used for our data format is used for primary data collection. So some colleagues have collected data from kind of 100 farms in Brazil and structured them up and are running a life cycle assessment over them. And people are also adding these kind of labels to products using our data. So this is a company called Bondra. They take our models, they've got their own activity data, they run our models and generate these kind of eco labels. So that is it for my demo. Hopefully I've showed some applications and explained at a high level what Hestia does, and I'm going to hand over to Juliet for the next part. Thank you.
Yeah. So as Joseph mentioned, I'm going to do a bit more of a demo. I'm going to show one of my uploads. I'm mostly going to focus talking a bit about Palm, because that was what I focused on uploading for the sort of first few months of Hestia. And I'm going to talk about where we're at with Palm data on the platform and show you the average data. So first step is I'm going to try and share my screen. Is that full screen? Can people see that?
So,
Yeah,
Yeah.
good.
Okay, perfect. So this is an upload based on a paper that was looking at producing methane from the palm oil mill effluent produced from crude oil. So this is how our uploads are usually structured. You can upload in Excel, in CSV, or in JSON format. Usually we choose to upload in Excel just because it's a lot easier to actually create the upload. So to start off here, we've got the important cycle information, these pink headers here. So this is things like the end date, how long the cycle lasts for. So on a plantation, this is usually a year, and then a cycle will cover a year of inputs and a year of products. We have the functional unit here. So for cropland, all of our inputs and products are all normalized to a hectare. So you can easily compare between yields, for example, maybe fertilizer inputs. And over here, we have our default method classification. So this allows us to show where the data has actually come from. So in this case, I think this was verified survey data because I think it was actually a government report. Often a lot of papers are non-verified survey data, or physical measurement is another one, usually when a experimental site has run a trial and have actually gone and measured everything, and we know that for certain. So that's the first section of my paper. And then to follow on from that, in these blue headers here, we have the source information. So this is usually, if it's a published paper, just the DOI, and then Hestia can automatically find all of the other information and link directly to the DOI in the source itself. We also put the original license. So everything that we upload to Hestia, we make sure it's open access. Following on here, we have the site information. So here we have what site type it is, whether it's cropland, whether it's a processor site, where the site is. So this was just a country level LCA. So the site here is Malaysia, but we can add latitude, longitude, very specific, or even just a more specific region. This is also where information would be stored about measurements that have been taken. So like Joseph mentioned about soil carbon measurements. And this is also where we store past and present management data. So for example, if you know that an oil palm plantation was oil palm 20 years ago, you can add that data into your upload and it will override our land transformation models. Following on from this, we have practices, which is a bit of a general term, but basically covers things. For example, for a plantation, it would cover things like the plantation density, the lifespan of the plantation. It would cover any particular practices, such as the tillage that is used, or what happens to the crop residue that is produced. It also covers things like certifications. So if this was, for example, an MSPO certified or an RSPO certified site, we could record that information here, as well as like organic versus conventional cultivation. And then moving on from this, we have our inputs. So here, this first cycle is a fruit production cycle. So we have our saplings going in. For the oil production cycle, we have the fruit that's needed, and we can add transport for these input terms. So how far away they were moved. Can add diesel inputs if you know how much diesel is used to move them. And this is where everything, so like fertilizer, pesticide, water use, Basically, everything that is used up in the cycle goes into this section. And moving on from this, we have our products. So we have our oil palm fruit, our crude oil, and the digestate, which the mill effluent that was processed. So we record our values. Basically, all our units are almost always in kilos for things like this anyway. We can record the fate of the product. So for the fruit, this was processed. I haven't recorded it here, but this crude oil will have been sold. And we can record whether it was a primary or a secondary product, and that just changes a little bit of our modelling. And we can also record properties. So for example, here I've recorded the pH and the BOD and COD content of the digestate that was produced. In this upload, I also have a transformation. So in this upload, I think they were burning the shell and the kernel of the palm that's produced from producing the oil and using that to create electricity, which was then used in the cycle. So I'm able to record that here. So that process can then be modelled for its emissions, and this electricity can be taken into account. Finally, or not quite finally, I have my completeness fields. So completeness is where we record basically how complete the data is. So for example, if this paper said that they used fertilizer, but they didn't tell me how much, as I think has happened here, I would set my fertilizer completeness to false. And when we do the average cycles, as Joseph was explaining, we take all of this completeness into account. So we only use cycles that we know are complete and that we know have that, for that particular category anyway, the inputs and the values recorded. And there's quite a few different categories, things like fuel, soil amendments, pesticides, water, and quite a few other ones. And then finally, we have our impact assessment. So mostly when I upload, I leave the impact assessment section blank, and I just let Hestia recalculate an impact assessment. However, you can also add in your own impact assessment if you, for example, have calculated your GWP and you want to see how that compares to Hestia. Then you can upload that. You can explain what allocation method you used, whether it's mass, whether it's economic. So yeah, this is basically what my upload looks like from my perspective when I finished it. And then if I go into this, sorry, I just need to switch which screen I'm sharing. Stop share. Okay. So if I go into Hestia now, first thing to do is to sign in. Anyone is free to create an account on Hestia. I don't know if Joseph mentioned this, but you can also do private uploads, which means all of your impact assessments and things will still be recalculated. Your data just won't be publicly available on the platform because it needs to be checked and verified by a member of our team for them to be publicly available. So if I sign in, it takes me to my upload dashboard, which just shows me what I've uploaded, and I've got this platform news section for any model releases or like glossary or schema changes that I might need to be aware of. And then if I go into data upload, I can choose a name for my data set, which I'll choose here. As I said, you can upload in Excel, CSV, or JSON. I've just using the first sheet, and if I click submit, it will then pass through our upload pipeline. So you can see the pipeline, hopefully you can see on the right here. So there's various stages that an upload goes through before it can be validated and submitted. So the first few stages are mostly just checking that all your column headers are right, all your terms exist in our glossary, that the DOI that you put is findable. And then these data compatibility and data validation stages are a bit more specific. So for example, for data validation, it would be checking that none of your numbers are negative, that if you've put in a value that's a percentage, it's not over 100. If you've said that a plot is, for example, rain-fed and there's no irrigation, but then you've got a water input, that would also come up in validation. So it's basically a place to try and weed out the errors that people can make in uploads, and also a place to remind people to do things. So, for example, for this upload, it has passed, but I have some warnings that have come up. So, for example, for property, it's telling me that the value that I've put in is substantially different to Hestia's default value. So it's suggesting that I just double check that it's not an error. I have not specified the fate of the crop residue. I know that Hestia does have a DAC fill for that, but it's still important information to be added. And I've not specified the type of tillage. So these are just general reminders to sort of get people to double check their upload and make sure that they haven't missed anything out. But I can go into and show you this source, or I should be able to if I search for it in our Explorer. Here it is. So this is what a source looks like on our platform. As you can see, there is an original and a recalculated tab. So in the original, there's not a lot of site measurements. We're missing emissions and we're missing our impact assessment. And if I switch over to recalculated, and go back to the top, you can see that now we've got some site measurements filled in. So these are all filled by mostly geospatial data sets. So the more precise the location we have for where a cycle occurred, the more precisely we can fill these in. At the moment, we've got biomass, organic carbon, and the eco-climate zone. We've also, management data has been added. So this has added in some historical land use of forest and cropland. And if we move down to emissions, you can see we've got our emissions split out into tier 1, followed by background emissions. So this is things like inputs production, and I think finally is the like not relevant section. And if you go onto the recalculation logs, it's going to tell me that you can see, for example, find a model that hasn't run. This model hasn't run because there's no waste in the cycle, but you can check, for example, if you wanted a tier 2 model to run instead of a tier 1 model, you can go into your upload and check, okay, why hasn't the tier 2 model run? What more data would I need for that to happen? So all these recalculation logs are all available, and you can go into the docs and see what the model requirements are. Our impact assessments have also been added. So we've got a few different sections. We've got the emissions, which is essentially just a normalizing of the cycle emissions, taking into account the economic value share. We have the resource uses, your impact indicators. This is things like your GWP. And finally, you have your endpoints. So this is things like damage to human health daily, and some of the recipe 2016 endpoints. But you can choose from here which model you would like to look at. So if I choose recipe 2016, I can see the values for all of those endpoints. And at the bottom here, as Joseph showed, we have the driver chart, which can show you this. I think if I go into palm fruit, most of the damage is coming from land occupation. If I look at GWP, similarly, a lot of it is coming from land transformations. This is the above and below ground stock change. And we can look even further and see, okay, there's a little bit coming from fuel combustion and inputs production as well. So that's what an individual source looks like. And you can have a play around and go into the individual cycles and see what they look like. And I'm just going to talk a little bit now about the aggregated data, so the average data that Joseph was talking about and where we're at with palm fruit. So this is our data. Oh, pardon me. This is our data explorer. So you can filter by what product you want to look at, potentially what region, so like a particular country. You can filter for a particular practice. So for example, if you only want to look at organic cultivation. So for here, I can start filtering by oil palm. And this is the chart that we get that comes up. So this data is based on about, I think, 25 sources and about 200 cycles. Most of the papers that this is based on are all surveys that have then been averaged, so we don't have the original data. So that's one thing that we'd really like to improve, is to be able to get original survey data for Palm, but we just haven't found it at the moment. But as you can see on the side here, so we've got Indonesia 1990 2009, Indonesia 2010 2025, and then the same for Malaysia. And as you can see, Indonesia is coming up the highest recently, followed by Malaysia in 1990 2009. This is mostly due to our current land transformation model, which only looks back 20 years. And so Indonesia, which has had more recent deforestation, has more emissions than Malaysia, whose deforestation happened longer ago. A lot of this is also coming from organic soil cultivation. But we know that is a model that needs to be reworked a little bit, but that's people growing palm on like peatlands, for example. But we can check this. You don't have to take my word for it. So if you go into one of the average cycles, and you can scroll down at the bottom and look at the drivers chart for example, for the GWP, and you can see you've got organic soil cultivation at the top, followed by all these biomass stock change, which are mostly the result of our land transformation models. And we also have a data quality score on our aggregations. So all of these get verified by us, and they get a quality score depending on what emissions are missing, how many cycles they're based on, how close they are to FAO yield. I know for palm it's something that we're not very close, and we're overestimating quite a lot, which is something that I think I'd quite like to improve. And how complete the data is. There's certain key areas like fertilizer and pesticide that need to be complete for this to count towards the quality score. But yeah, that's pretty much where we are at with palm for the time being. And that's what the platform looks like. Yeah, hopefully that was at least semi-clear. I think that's about it for me.
Yes, thank you, Joseph and Juliet. I'm sorry, Patrick. Now we have Pak Nugroho here. Yeah. Pak Nugroho. Oh yeah. Okay, I just greeting to them. And we have also Professor Supriyadi Alinandar here. So I will give time back to Mala as Master of Ceremony. Time is yours, Mala.
Hello, I'm back again. And good afternoon, everyone. So we're here with our chairman of Energy and Manufacture Research Organization from BRIN, and he would like to welcome the speakers to this webinar, and he would like to have the opening speech first. Sorry to cut you, Patrick, before you talk. Please welcome our please welcome our chairman, Professor Supriyadi Alinandar.
Okay. Hello. Okay. Thank you very much. I'm sorry because I coming late because I have meeting with the chairman of National Research and Innovation Agency, Pak LTH. First, I would like to thank you very much for all our honorable guests, esteemed colleagues, respected partner from University of Oxford, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to all of you. It is with the great honor and utmost pleasure that I extend a warm welcome to all of you to amazing webinar today, marking the initiation of the highly significant collaboration between the Research Center for Sustainable Production System and Life Cycle Assessment at the Research Organization of Energy and Manufacture BRIN in Indonesia, and the distinguished University of Oxford, UK. As we all know that the challenge of the advancing the environmental sustainability of agriculture system while simultaneously ensuring they provide nutritious food for the growing global population remain a critical and urgent concern. It is a challenge that the demand coordinated and immediate action on a global scale, particularly as we grapple with the undeniable impact of climate change and the increasing pressure on our food manufacture and system and also supply chains. Despite the considerable wealth of the data and farming practices and their environmental impacts, much of this information remains scattered, inaccessible and fragmented. This presents a significant barrier in identifying the most sustainable agriculture industries and products, thereby limiting our ability to make informed comparison and sound decision. In this context, the mission of Hestia initiative stands as a picture of progress by providing harmonized, accessible data and robust scientific model. Hestia seeks to bridge this critical gap. It enables farmers, food manufacturers, business, and policymakers to make well-informed decisions about the food production and consumption in a way that promote a greater environmental sustainability. The initiative data perform, I think the initiative data perform with its standardized format and open source model for estimating emission and resource use will undoubtedly be transformative in improving the transparency and sustainability of global food manufacture system and their supply chains. Ladies and gentlemen, so I would like to take this opportunity to express my gratitude to a team of the University of Oxford for their commitment to this vital cause and for their collaboration with us here in Indonesia. This partnership is not only the exchange of expertise, but also the long-term commitment to sustainable agriculture futures. I believe that through this cooperation, we can make this substantial and lasting stride in tackling the challenge and that lie ahead. The data and tools that will be showcased today are invaluable for enhancing our collective understanding of agriculture sustainability. More importantly, they offer the potential to foster meaningful behavior change within the farming practices, food manufacturing, and global supply chains. We find ourselves at the pivotal moment, one where the opportunity to influence change on a global scale is within our reach. I'm confident that the collaboration between BRIN and University of Oxford will play important role in addressing these challenges effectively. So in conclusion, I would like to extend my thanks to all those who have contributed to the organizing today's event webinar. Yeah, I look forward to the stimulating discussion that lie ahead and to the collaboration between BRIN and University of Oxford in this crucial endeavor. In trust that the today webinar will be an inspiring and enriching experience for all of us Thank you for your kind attention, and I wish you all highly productive and insightful session. Once again, ikan hiu makan tomat. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Pak Professor Chuk. Now, are you going to do the speech now? Yeah, okay.
Thank you. Thank you, Mala. Thank you, our chairman of our research organization for energy manufacture, Pak Chuk. Really sorry for delay of our opening remarks since the chairman of National Research and Innovation Agency of Indonesia, BRIN, asked us to have important meeting, and then the meeting was delayed in more than 1 hour. Really sorry, Juliet, Patrick, and also Joseph, for really sorry for that. So they're all of the distinguished speakers and participants. I would like to extend my deepest gratitude for your participation in today's webinar. First and foremost, I must sincerely apologize for our delay arrival at the session. We greatly appreciate your understanding and patience. It has been an honor to be part of this important event, marking significant collaboration between our research center for Sustainable Production System and Life Cycle Assessment at the BRIN, and also the esteemed University of Oxford and Stockholm University in Sweden. Discussion today, I follow the discussion, even I cannot speak, really sorry, are vital in addressing the challenge and we are facing in ensuring environmental sustainability in agricultural system while providing nutrition food for a growing global population. I would like also to express my appreciation to all of our distinguished speakers, Mr. Joseph Fur, Miss Juliet, and also Patrick. We have met 2 times now, Patrick. Thank you for coming and then have extended collaboration with our institution in BRIN. Really, thank you, Patrick. And also the panel attendants for sharing their valuable insight and expertise. The knowledge exchange here will undoubtedly have a positive impact for our effort toward sustainable food production and global supply chains. For your information, this webinar also followed by some of the distinguished participants from FAO, Food Agricultural Organization. Since last week, I distribute and I dispatched the poster to FAO in headquarters. So I believe that some of participants here coming from FAO and other international or multinational institutions. Thank you very much for coming. Thank you once again for your engagement and contribution. I look forward to continued collaboration and we move forward in tackling the critical challenge together in the world today. Thank you very much. Thank you. Thank you, Juliet, Joseph, and also Patrick. Thank you.
Thank you for our chairman, Pak Nugroho and Professor Chuk, for opening the webinar. And now we're moving forward to the next speaker. And the process is yours,
okay.
Mr. Agusta.
Okay, yeah. Thank you very much for the time. So, thank you very much, Professor Chu and Pak Nugroho. So we continue to the. Before the next session, I think if there is some question related to presentation from Juliet and Joseph, please go ahead or raise your hand or put some text in the chat. So I think there is still no question. Maybe I also have question, but later after Patrick, I think. Yeah, please, Patrick. Time is yours.
Terima kasih.
Terima kasih.
Hi, everyone. So I'm, first of all, thank you so much for having us. And I'm going to be brief so we can have some space for question as well. And I just wanted to tell, without slides, a little bit about how we worked with organizations similar as BRIN before. We have several active collaborations. I think Joseph mentioned some for example, with CIMMYT, which is one of the CGIAR centers, where we've been adopting large data sets from farmer surveys, and we can plug that into Hestia, and in return, we can generate large LCA data sets for those different data sets. We have done similar things in other parts of the world, and I think it would be super interesting to explore how we could collaborate with BRIN. So as some of you might know, I already work a lot with Viloso with lifecycle assessment. I've been working with a lot of lifecycle assessment of different ikan, but we're also very interested to work with palm oil and other commodities in Indonesia, because we know that Indonesia is a very, very important food hub in Southeast Asia. So I'm going to round off there, and I'm going to simply open up for discussion, because I think it's more important that we talk about any questions or ideas for collaboration, etc.
Yes. So would you like to share something, or we just discuss?
I think I do not have much more to say.
Okay.
So I think it's
Okay.
at best at this point that we talk a little bit, if there's questions
Yes.
about the platform, about
Yes.
the interoperability, how we've been working to date,
Yeah.
how you foresee that we could bring this collaboration forward,
Yes.
and
Yes. Yes.
what is the interest
Yeah.
for Hestia at BRIN.
Oh, okay. I have one question actually, if there is no question. So I have question to three of you. So before that, I want to know that how long you established the Hestia itself. I think there is Hestia is a platform that already start several years ago. Is it right? From Oxford University, but in the case of agriculture, I think it's in Hestia is all related to agriculture and some fisheries, and then I mean how long you can establish the one platform of this. So, and this is the first question, and then the next is this platform can compatible with the like commercialized software or platform in GSP or in the Simapro, and then in the Zolka and everything. For example, for us like practitioner, we use collect the database or data set from this platform. How about the compatibility with the commercialized journal? I think this is two starting question from me. Thank you for Juliet and Patrick, and yeah, Joseph. Thank you.
Yeah. Thanks, Gustav. So the way that the platform works is that, well, first of all, we've been working on Hestia for roughly 5 years, I think now. But the team has grown very rapidly. We were in the beginning only a few people, and now we are closer to 12. We're probably more than 12 today. Many people work part-time, but there's a good core crew that works full-time, just developing the platform and uploading data, improving the glossary, doing the programming. And part of the things we do is to make it interoperable with other software. Some of the LCA specific software that you might be familiar with, such as eConvent, which is actually it's a database for background processes. We do collaborate actively with eConvent because we use some of their data for background processes, for example, fertilizer production, fuel extraction, fuel refining, etc. We are also trying to build converters to other LCA software formats, such as the EcoSpot. Some of these prove more difficult than others. part is because in Hestia, we often have more metadata related to agri-food cycles. So of course, if you think about a agri-food cycle, you are very, very dependent on the geography, the type of soil that it's being grown on, the sort of biota where it's grown, etc., etc. So we have more metadata than is usually contained in normal LCA formats, which means that we don't have any easy export functions. But for the Hestia platform, you can upload and download data in CSV format, which is not very cumbersome then later to import to any LCA softwares, if that's how you like to work with it.
Yeah. Thank you very much. Bapak Ibu, is there any question? Apakah ada pertanyaan? I'm searching for. I think Pak Edi Wiloso is not joined today. So yeah, it's very interesting because yeah, maybe I have a third question actually. So because Pak Nugroho just said about the FAO, so I think in the internationally there is also some model, but I think it's they also quantified the carbon dioxide and LCA, I think, but I think is there any approach different between the such as from FAO is GLAM model, GLAM, or between this Hestia and their model, or this is similar platform which is special for the UK. I'm not sure, but for as I see in the presentation from Juliet that you also collaborate with DEFRA, right? DEFRA UK. So it is I'm wondering about the emission factor between the you are now working in the Leiden, which is familiar with the CML, and then Juliet familiar with the factor from DEFRA. How you collaborate each other and how sensitive the result based on this factor. Thank you very much.
Thank you for that question. So we do have a dialogue with FAO as well, and we have a dialogue with DEFRA. But in terms of comparing our models with the things like GLEAM, we haven't gotten that far yet in the comparison. But GLEAM is a very different, more simplified model. I mean, that is kind of an Excel-based model that is building on static numbers. With Hestia, we use gap filling to pull in relevant geographical data and temporal data for different locations. I think with FAO, they have an interest, especially for the glossary and the schema that we have developed to maybe adopt this. And I think that if you ask me personally, I don't know, the GLEAM was a good thing when it came out. It filled a need, but it is very simplified. And it's also only for livestock, so you don't have anything for other agri-food commodities. And with Hestia, for Hestia, we also allow for aquaculture, and we're now soon going to expand and add captured fisheries as well. So we have all of the pivotal food source commodities.
Okay. Yeah, it's very interesting. But yeah, is there any question? So I just not just from me the question. Maybe we have also one expert, Pak Dudi. Are you there? Prof. Dudi, Pak Dudi Iskandar, or Bu Ira? Are you there? Are you join? Amal, I have question. Okay.
Can I ask a question in return?
Yes, sure.
Yeah. So what it? So I mean,
Absolutely.
I've been of course working with Para Eddie Veloso, and
Mm.
we work with things like the Susuenas data set.
Yes.
But do you? I'm assuming BRIN also have disaggregated data sets on on farming practices for different commodities, right? At kind of
Yes.
a farm level.
Yes.
And
Yeah.
what kind of resolution are they, and how often are they updated, and how large do you usually conduct them?
Yeah. Actually, this is not my right to say something about this data set, but yeah, we are starting. As I know that we are starting to develop from the data set into the database, but uh, this is just my opinion. So because I'm interested with the other approach, top-down approach of LCA in the EAIO, Environmental Standard Input Output. So maybe now we are collecting based on the practices in the field, or tier 3, yeah, research in the field, and then collect the data set and go to database. Yeah, sure, absolutely. We have several data set already in the agriculture. For example, for the palm, absolutely, palm, and then coconut, I'm not sure, but other coffee and other thing, I think several of our researchers already collect some this inventory, and this is for agriculture base. And for fishery or blue economy, so I'm not sure. In myself, I'm collecting the data for the seaweed, not fishery but seaweed, but related to fishery, I think Pak Edi or Prof. Edi, they are doing the fishery, and then for the cattle or yeah, for the cattle, I think there is some researcher here, Fensa and other. I think for the yeah, Fensa, are you here? Or Pak Dudi? Not sure. Yeah, for cattle, and oh yeah, we also have collecting some data, but this is not my field, so I cannot talk a lot. Yeah, so my field this year I'm concerning only in blue economy in seaweed. So yeah, because I'm interesting how you collect the such huge of data, because these days there is so many platform for collecting this LCA results, as you know, right? Like from Glad and others. So I'm interesting you talking about the resolution, how 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 higher the resolution of your data, or how sensitive of your data is very interesting. So maybe yeah, this is if in the future we can collaborate in the agriculture base, so maybe we can make a team in Indonesia, who is the in charge in agriculture, who is in charge in the blue economy, who is in charge in the fisheries and other. So after that we can collaborate together. I think I need someone else to talk here, but I'm not sure they why Fensa. Halo Fensa or Bu Nadira.
Can I ask a question, Pak
Yes, Bu
Agusta?
Meda. Yeah, Meda. Okay.
Yeah,
Yeah, please. Yeah.
thank you for this opportunity. Currently, I'm starting my PhD in University Indonesia, and my topic is about urban farming. So I would like to know how can Hestia platforms data and model tools be utilized to effectively measure and mitigate, especially in for water impact of various agriculture practices, because this is what I am going to do on my PhD, and I would like to know whether a Hestia would be maybe one of my platform for doing the research, especially an urban farming assessment on water mitigation. Thank you.
Thank you for the question. Yeah, I mean, one of the things that we provide, and that's I think is very useful for anyone who is doing agri-food LCAs, is that we provide a lot of emission models that we have coded up into Hestia. And in your case, for example, if you talk about water evaporation rates, we do provide models for this that will estimate it based on the temperature, how humidity on your location, how much water would actually evaporate. Similar for other emissions from that system, for example, nitrous oxide emissions that happen related to nitrogen fertilizers, methane emissions, etc. So we're coding up more and more of these, and these models are sometimes more or less complex, but it takes time to get used to them. And in that sense, Hestia can either help you to provide the calculations online, but we also do give you the possibilities to understand which models are driving behind, and also identify which of the models are most appropriate, and to which tier can you have the highest tier for your models to make your emission estimates. So I think very much that you could explore this. I don't know exactly how the systems look, how uniform they are with more conventional farming systems, but I think you should definitely explore it.
Got it. Thank you.
Okay.
Yeah.
Okay. Is there any question? Mala, do you have question?
Yes.
Okay, please go ahead.
It's a bit basic question. I was doing research on also the water impact. Sorry, the food industrial system impact on the water system. I was doing it with my professor in Wageningen, Netherlands, and there's a tricky question that I got from my colleagues and from my professor. Is it how the Hestia will accommodate the customer choice into the calculation? I mean, for example, when we pack the food, how we pack the food, how the food is distributed into the customers, it's also impact several yes, they also have several impact on the environment, especially on the water, and how that incorporated into the Hestia calculation, and also how is the scope of the Hestia? Is it cradle to gate, cradle to grave? Because the customer choice is usually put behind. Okay.
Yeah, it's a really good question. So Joseph's original paper, he went farm to the actual shop floor and did take into account all of the packaging processes. At the moment on Hestia, we're just to the farm gate currently. At the moment, we're working on our processing cycles. So this is things like the production of palm oil, like soybean meal for feed, and working on the methods, because one of the issues that we have here is there's not a lot of data on how these processing things take place, but they are vaguely similar between countries. Like usually your inputs are far more constrained than they are for an agricultural process. So we're looking at potentially using global average proxies to say, okay, well, this is what we'll say the average effect of processing soybean is. Okay, so what's the impact if your soybean comes from Brazil and is transported to Germany, for example? So that's what we're working on at the moment. But yeah, end goal is to include all the packaging, all of the transport, and yeah, really account for all those impacts. It's just probably a few years in the future. But yeah, that is definitely the goal.
Okay, all right. Thank you, Julia.
Maybe from Pak Nugroho. Okay. I think is there any question? Pak Dudi is still here? Pak Dudi? No? Okay. I think if let me conclude something from presentation from Juliet and Patrick and Joseph. So yeah, maybe overall we understand your platform now. So we will explore after this and try to explore the Hestia, and maybe we can find some interesting part based on our research, and we can contact all of you if we want to collaborate, I think. Okay, I think that's all. So time is, I will get back to our master of ceremony, Mala.
Okay. Okay, thank you for all the speakers today. And now we really enjoy the the meeting, the webinar, the knowledge also. And I think if we don't have any more to say, I think that's all from us. If there's something to say from all of you, maybe the three of you. Oh,
I just want to say, first of all, terima kasih for letting us do this, and thanks you,
Okay.
Pak Gusta and Mala,
Yeah,
for organizing this. And for everyone who's here, I would just want to highlight that Hestia is an open access, free to use platform. So you can go in and create an account now, and you can start playing around with it. There's no fees or costs involved with it, and it's a collaborative research effort. So we're very happy to assist you or anyone who wants to contribute to the platform.
Yes, we will explore after this.
we will definitely dip into the website.
Yeah.
Okay, all right. Thank you again for everyone, and enjoy your afternoon and enjoy your day.
Yeah.
Bye bye.
See you again. Yeah.
Thank
Thank
you.
you. Bye bye.
Thank you.
Bye.
Bye.
Cheers.
Terima kasih.
Thank you.
Oke. Terus pas pagi juga, kasihan. Langsung kita tutup berarti ya. End meeting.